what do we do? Okay, we know material property. That tau max is equal to stress U divided by 2. Right? So this will be equal to 42 times 10 to the power 3 divided by 2. So this is equal to 21 times 10 to the power 3 psi. Okay, so this is your maximum shear stress. So this has to be the largest diameter, okay, in the 3D mold circle. So we know from here, right, we can still use the same 3D mold circle. This is still valid, right? So we know the circle look like this. Yes or no? So when the circle look like this, we know that tau max is equal to stress max minus by stress mean divided by 2. Okay? So all we need to do now, right, is and we know the expression, right? So stress max, stress mean. So we know that stress max, we did this before, and mean is equal to stress average plus minus by R. So we know that tau max is equal to what? Stress average plus R minus by stress average minus by R, and then the whole thing divided by 2. So this will be equal to what? R, because we have what? At the top, this can cancel off. We have 2R over 2, then this is R. So all we need to do now is find the radius of the circle, right? Or we know the radius of the circle for this case. Okay, for this case, we know the radius of the circle because we know that this is tau max. So from here, we know that tau max is equal to what? Is equal to R. Okay, tau max is equal to R. So from here, again, the formula is still the same. So now we already know what is R already, right? R is equal to what? We found the radius is equal to 21 times 10 to the power 3 psi. Okay, that is Tresca criteria. Okay, so from here, right, again, we apply the same formula. Shear xy is equal to R squared minus by stress average squared. And we have all these values. So this will be equal to what? This will be equal to 21 times 10 to the power 3 minus by stress average, which is 16 point, can't remember, our stress average is equal to what? 16.977. Okay, 16.977 times 10 to the power 3 and the whole thing squared. So this work out to be equal to what? This will work out to be 21 power 3 squared minus by 16.977 power 3 squared. Square root the whole thing, 12.36. Times 10 to the power 3. So from here, we know that shear xy is equal to Ty over pi over 2 c cubed. Okay, we derived this earlier. Okay. So torque due to y, the y-axis, the shear xy is equal to 12.36 times 10 to the power 3 multiplied by pi over 2, 0.75 cube. So this will be equal to what? 12.36 power 3 times by shear pi divided by 2 times by 0.75 power 3 is equal to 8.19 times 10 to the power 3 pound inch. Okay. And then also we still have to check. Okay, what do you mean by check? We have to check our stress A and stress B value. Okay, so this will be equal to minus 16.977 times 10 to the power 3 plus minus by the radius is 21 times 10 to the power 3. So 16.977 plus by 21 is minus 37.977 times 10 to the power 3 psi. And then the other value is equal to 4.023 times 10 to the power 3 psi. If we were to calculate the factor of safety, right? So the factor of safety is equal to minus 42 times 10 to the power 3, because von Mises also make the same assumption like Tresca, that the normal stress in compression and in tension is the same. And then this is equal to minus 37.977 times 10 to the power 3. So 42 divided by 37.977 is equal to 1.106. Okay. So what I'm going to do now is I'm going to take the value. I'm going to compare. Okay. So if we look at the shear x to y, so on this side is Tresca. And on the other side is von Mises. Okay. So the shear xy, earlier we calculate. We realize that von Mises, the shear xy value is what? Much higher, right? It's equal to 14.272 rather than 12.36. And then the allowable torque, right? So we calculate the allowable torque. So the allowable torque, right? You can see is what? 9.458 for von Mises. Okay. And then if we were to look at the factor of safety, right? And then if we were to also, I'm going to take the normal stresses or the principal stresses. So the principal stresses are higher. You can see that, right? The principal. So on the left-hand side is Tresca. On the right-hand side is von Mises. And the factor of safety is lower. So what does this mean? Okay, you can see for yourself, right? So this means that Tresca criteria is more conservative than von Mises. And it's always the case, okay? If you were to use Tresca criteria, right? It's more more conservative. Okay, so conservative means what? You have conservative means you have higher factor of safety. Okay, your torque is lower, right? And your stresses are lower. You can see that, right? Your factor of safety is the higher term. Okay, so now your I mean I know it's quite a lot, especially okay, we started with von Mises and then we go back to Tresca. So let me do a really like quick summary on this aspect. Okay, so the summary, okay, what your mind should be like, okay, when you're using both criteria. And it's not that difficult, okay? So let's do a summary. Okay. Okay, let's do it. So like what we have done before, so I'm going to, on the left hand side, I'm going to go for Vomesis. Okay, and it's known as a maximum distortion criteria. And then on that we have Tresca, which is based on maximum shear stress. Okay, maximum shear stress criteria. So for both of them, what is common? If the thing that's common is common for both of them, you have to what? Construct 3D mole circle. Okay. So with with Vomesis, regardless how the mole circle, so the mole circle can look in two ways. The mole circle can look like what I've drawn earlier for all of you to see. The mole circle can end up like this. Okay. Mole circle can end up like this. Right? So there are two possibilities. Your mole circle can look like this, or your mole circle can look like this. That's why today's lecture, I started by sketching the 3D mole circle for you. Okay? Or your circle can look like this. Right? So there's two ways that your circle, after you construct your mole circle can look like the one on the left hand side, okay, or the one like the right hand side. Okay, so the one on the left hand side, we call it stress max, or stress max is not equal to 0, stress mean is equal to 0 on the left hand side. On the right hand side, stress mean max and stress mean are not equal to 0. Okay, so if we were to look into Vomesis, all we need to do for Vomesis, we just need to find what is our stress A squared minus by stress A stress B plus by stress B squared. We need to ensure that it's less than stress U squared. That's it. Okay. Whereas on Tresca, right, when stress max is not equal to 0 and stress mean is equal to 0, then we know that tau max is equal to stress U, right, divided by 2, and this has to be equal to our what? Our stress X divided by 2, right? So then so this is one condition. Next one, when stress max and stress mean are not equal to 0, tau max is equal to the radius. That's it. Okay. And the common thing for both of them, when you finish, you have to check stress A and stress B must be less than stress what? Must be less than stress U. Okay, for both of them is that. So this is a nutshell what it should be. Okay. The thing is you have to construct what? 3D mole circle. And constructing 3D mole circle by no means is any more difficult than constructing 2D mole circle. Okay, and you can see for yourself after our calculation, okay, after our analysis, right, from here, when we compare Tresca and Vomesis, right, we know that Tresca criteria, important thing to note, Tresca criteria is more what? Conservative when compared to Vomesis. Okay. Right, that's all for our criteria. The next topic that I'm going to do, and this topic is It's not difficult, but it combines whatever we have learned from week